This is a challenge problem solution on solving an inequality with uh, exponential functions. So the first thing I want to do is I actually want to get rid of this negative exponent. It's kind of causing me trouble. So let's, and hopefully we're all familiar with the notation I use here, or the jump. But remember, that t to the negative 1, that can become a fraction 1 over t. That gets multiplied by that quantity 1 minus e to the t, and I'm comparing it to 0. So this looks a lot like a rational function compared to 0. So we're going to want to make a sign diagram for this case. And if we want to do that, we need to analyze both the vertical asymptotes and the zeros. So my vertical asymptote is going to be t equals 0, and that's just pretty straightforward. That is the solution. Next, I can solve 1 minus e to the t equals 0. So I want to think, what value do I have to plug in for t to get 1? I can try and solve for this, but it gets into some circular reasoning. Reason you'll see is if I isolate, take the natural log of both sides, well, now I'm asking myself, okay, the natural log of 1. What is the natural log of 1 asking me? It's saying e to what power equals 1. Okay, well that is exactly what I'm asking right there. Um, but anyway, if you want to know the solution, it's e to the power of 0 gets you 1. So t is 0 in this case as well, because e to the 0 is 1, 1 minus 1 is 0. So I have two solutions for t 0, and now I kind of want to like analyze this and see what it's going to look like. And it's going to be an interesting looking sign diagram, but let's see what we have to work with here. So um, at 0, I have a vertical asymptote, and t equals 0 provides me a positive linear line just like this. Now let's imagine what that function 1 minus e to the t might look like. Well, I know that I have a 0 at 1 on my graph, right? So at 1, I have a 0. And if I think about what e to the t looks like, it's an ever-increasing exponential function. And so this should look something like this, right? It's kind of just lowering that point 1 on the graph. And so in doing, or oh, I messed that up. I messed that up bad. I'm sorry. Hopefully you guys are raging internally at my graph. It's going to look like this. Um, okay, hold on. So we have the 0 at t equals 0. Yes, that's right. Okay, looks like this, right? Not my best drawing, but I offset that t by 1. Anyway, that's what that function will look like. And so I'm negative for the negative values and positive for the positive values. So essentially, and this might get awkward to draw on the sign diagram, but if I kind of tried to mimic what's happening, well, what you'll see is if I choose a sample point right here, I get two negative values. Two negatives multiply to be a positive. Whoa, hold on. Okay, two negatives multiply to a positive. But if I choose a sample value here, I get two positives. So that interval is positive. And what ends up happening is that the only time that we're not greater than, or that we're not less than or equal to 0 is actually at the discontinuity, which is the vertical asymptote of t equals 0, because that's undefined. And so the actual solution to this is it's going to be defined everywhere except for that point at 0 because of that asymptote. So the final answer is negative infinity to 0, union 0 to infinity. So that's kind of a way that you can adapt a sign diagram method to making a more readable problem when dealing with inequalities and exponents.